Hello everybody, this is Todd Frazee and this is the video tutorial for modeling the TCOSE-14 part. It's called the cylinder retainer bracket and it's a sheet metal part. And it's important that you reference the correct drawing. So there were some issues with the assembly print, and you should be using this supplemental drawing as shown. If you don't have that, download it from Canvas in PDF format. There are some changes to the part. The most notable one is that the original design doesn't have bend relief slots in the areas. It didn't allow for the tabs on the end to be bent. So make sure you have that drawing ready and that the revision matches what the tutorial has. Okay, moving over to Fusion. So we're going to start by drawing a sketch. And that sketch is going to be representative of the inside edge of this front view, defined by the 64 millimeters in this axis and the 22 millimeters in this axis. So we're in effect do it like an extrude, but it's going to give us options based off sheet metal rules, what side of that edge to use and what offset and what size bend is in the corner. So we're going to start off with a base feature that is this hook, this C shape, and it's going to be 7 millimeters wide. Okay, so make sure you have this view ready to reference. Okay, here we go. We're going to go to, we're going to have a new file open, and before we do anything, we're going to save this, and let's call this the TCOSE-14- and your first initial and last name. So in my case, it's T Frazee. By saving before you do anything in the file, it creates a history for a recovery file in case you crash. Okay, we're going to go over to Sketch, and we're going to create ourselves a sketch. And we're going to go ahead and make this in the front view because that's how the drawing is laid out. And we're going to start off by, again, tracing the inside profile of the C shape. And you'll notice that I purposely have straddled where this line is coincident to the origin, and we're straddling the vertical axis. Okay, so as usual, like I normally do, you're going to go in and add constraints. So let's make sure this line here is constrained coincident to the origin. It should turn black. And then we're going to throw a line from origin straight up, and you can hit escape then. And we're going to left click on that line and turn it into a construction line. So now I have a line that is aligned with the center line, and we want that line to be sure that it's constrained vertically like this one is. Last constraint, we're going to make the endpoints of these vertical lines horizontally constrained to each other. That way they're the same length. Alright, moving on. We're going to dimension from center line to this edge on the left, and our drawing says that should be 32 millimeters. And that'll allow us to then measure from vertical line to vertical line and give ourselves an overall of 64. And the only dimension we should need now is the vertical leg, and it is 22 millimeters. Okay. And just for tidiness, I'm going to go ahead and align our center line horizontal with the other ones, and that way it'll fully constrain our sketch and we get our little padlock icon. So you've just finished everything you need to define that. So let's hit Finish Sketch. And we're going to go, at this point, to the Sheetmetal package. Now in Sheetmetal, the Sheetmetal rules are parameters that are set ahead of time. And so for this part, it defines things like bend radius, bend reliefs, material thickness, things of that nature. And then what it allows you to do is extrude a shape, and then it puts in the rules for you to be able to unfold the shape so that it can be cut, say, on a water jet or laser or plasma cutter. So we're going to go to this Sheetmetal rules, and we're going to go to aluminum. Now our part is called out as brass. There isn't a standard brass called out in the library. If you were to be thorough about this, you'd want to find a source where you could download the properties for brass. But for learning purposes, we're going to treat this part as aluminum. And what that affects is this K factor here. It has to do with how it calculates the bend for that particular material. So your current settings are probably going to be different than what you have on the screen here. But you want to select on this pencil icon, and you want to edit the rules for aluminum. And the parameters you want is a thickness of 1 millimeter, because that's what our drawing says our material thickness is. You can leave these other two at default, and then you're going to open bend conditions. And this drawing calls for the original drawing calls for a very tight bend radius. I don't even know if this is really achievable, but we're going to go with how the part was designed. So it defaults to the thickness of the material, which gives you a fairly large bend radius. And we want to change this to 0.01 millimeters. The next thing you want to do is we're going to go down to relief, and it defaults to the thickness of the material. I've done a little research on water jet, and with a fine tip we should be able to achieve half a millimeter for bend relief width. This is a very small part, so we want the bend reliefs to be as thin as possible, which will leave more material for the stoutness of the part itself. That should be all you have to do in the rules. And if you forget to set these up front and you start designing a part, you do have the opportunity to come back and change it. So let's hit save, and then we'll hit close. We're going to go to the Sheetmetal menu, and we're going to create our base flange. So we're going to make a flange, and we're going to select the entire line. Now there's a bunch of parameters here. We're going to go down them one by one. So our distance is going to be, we're going to set that is 3.5, and that's half the width of our part. But the reason we're doing it that way is so that we can build it symmetrically on the plane, and we're going to direction of extrusion to symmetric. Okay, and so we'll have 3.5 millimeters per side, adding up to 7 millimeters. We will be creating a new body, and we want to make sure we selected the aluminum rules. It defaulted to stainless. Now, one parameter I skipped over is this side. You want to rotate the model and zoom in on it. Now, we dimensioned our sketch on the inside of our sheet metal part. So you want to make sure that it says, it may say side 1 or 2, but you want to make sure that the material that it's previewing is on the outside of the line you sketched. Otherwise you'll be off by the material thickness. Okay, so in this case it's already defaulting on my screen, but to demonstrate I'll show you. If I go to side 2, it's then going to define the sheet metal part based off those being outside dimensions. Okay, so let's switch back to side 1, and it should look like this. And we're going to select OK. Now you should have this clip looking piece now. The next step is we want to add a little cross piece in the center, and that is going to be for this these two tabs that are bent upwards here. We need a base for that. So what we're going to do is we're going to add just a basic extrude to our base flange that's going to be 6 millimeters wide, and it's going to project 19 overall. So let's go back to our model, and we're going to pick a sketch, and we're going to select the top surface of our model, and we will draw a rectangle that goes over the origin. I hit escape, and we're going to use a couple lines. We're going to place a line from top middle to bottom middle of our rectangle. Okay, and then we're going to make another one that goes from the center bottom edge of our base flange to the other center. Okay. And now we're going to left select and then right select and turn both of those lines we just made into construction lines. What we're going to do is use these lines to align our part on center. So now we can take the vertical line, and we're going to hold the control key down and select our horizontal construction line, and we're going to force the centers to be coincident by picking on midpoint. Okay, I didn't have mine vertically constrained, so I just added that constraint. Make sure it's vertically constrained. This way we can do our dimensions and keep this part symmetrical. Alright, so our overall width of the flange here is going to be 6 millimeters. Okay, and then it's centered on our part, so we should have 3 millimeters per side. And then our distance overall should be 19, like our print. Okay, and so you should have this fully constrained now with just the 2 dimensions, provided you have all your relationships on midpoint. Okay, we're going to select Finish Sketch, and we're going to do a standard extrude. And at this point, I always go to a 3-dimensional view, and we're going to be extruding down because we select on this plane. And so we're going to select the profiles on either side zones, and then our profile is going to be one-sided. Instead of doing distance, we're going to use to object, and this will allow us to spin around and select the bottom of the part. It'll not only flip the direction of the extrusion, it'll make it the same thickness. And we want to make sure this is unjoined so that it merges into one solid. Alright, so we should have this bow tie with the flanges sticking up. Alright, we have a few more steps here. Probably save early, save often. Okay, next we're going to go to the flange tool. We're going to select flange, zoom in on your cross, and we're going to select 4 edges. 1, 2, 3, 4 edges. Okay, now we are going to put in our height. So this would be the height from, as the drawing calls, which is 7.5 millimeters from the upper face. So we're going to type in 7.5, and we get these flanges sticking up. Now our height datum, we want to make sure we have that set correctly. We're going to look at it on end, and we have different options. We have outer faces, inner faces, and tangent to bend. Okay, so it defaults to outer faces. So what that means is it's going to measure the distance from this edge to the outer edge. But our dimension in the drawing is actually from this edge here. And so we want to match that. So we're going to switch to interfaces. And so the dimension will be from the inner wall to the top of the part. Otherwise, you'll type in 7.5 here, but it'll be measuring from the outside of the part, and your flanges will be a millimeter too short. Now our bend position, you have the option of doing inside, outside, adjacent, or tangent. Our dimensions, it defaults to inside. Dimensions actually called from the opposite face here. So we're going to pick outside. Okay, and that means it's the outside of the line you actually selected on the perimeter. If you don't have that perimeter on outside, the distance between here is going to be off by 2 times the thickness of the material. We're going to select OK, and there we have our flanges. Now, it's always a good idea to go back and inspect a few things. So I'm going to measure between these two faces here and verify that it is 6 millimeters and matches my drawing. We'll pick the top face of one of the flanges and the base flange, and we should have 7.5 millimeters. Okay, moving forward. All right, so the rest of this part, we pretty much have this part defined as far as sheet metal is concerned. We're just lacking some holes. All right, we need to put holes in the faces of these flanges, and then there's a notch that's on the ends of these two flanges, the tall flanges. So first we'll go and make the notches in the tall flanges. So I'm going to create a sketch, and we're going to put it on the face, outside face. And I prefer to start with just a circle, and we will then create a line that's going to go from the center of the tab and go straight down to the center of our circle. That line, we're going to right click on it, and we're going to turn it into a construction line, and we want to make sure that it's constrained vertically. Alright, next we will draw a couple lines that straddle the circle we just drew. We will then use the tangent tool and make each of those lines tangent to the circle. Okay, so now we're going to switch to the trim command, and you can either select on the entities you want to remove, or you can hold the button down and an eraser should show up, and it trims it off whatever the eraser crosses. It did assume relationships with the edge there, and then we also need to trim off this inside of the circle. We don't need that. Actually, I'm going to close the notch with a full profile. I'm drawing a line from end to end there. Now we're going to define the radius size, which is 1.5 millimeters. It's half of a 3 millimeter diameter. And we need to define the distance between the center of the circle and the top edge, which our drawing says is 4 millimeters. Alright, everything's constrained, so you can hit Finish Sketch. We're going to do an extrude, and we're going to go through all, and we're going to use a cut instead of a new body. And we're going to select the zone inside of the horseshoe shape. Now that you notice the arrow is going the incorrect direction, and we're going to flip that. And it's going to cut through both tabs at the same time. We'll select OK, and we have our notches now. Okay. Alright, next step. We're going to create a sketch that's going to define the two holes. Now you could use the drill command, or you can use the simple hole to drill these, or 3 mm, or you can draw a circle. You can do it either way. You still have to set up a preparatory sketch if you're going to use the hole command. So let's go ahead and do that. You're going to go create. You're going to create a point, and you're going to put 2 points, one on each flange. First, we're going to set our constraints. We're going to make those 2 points horizontally constrained. Alright, now we're going to do a dimension from one of the points to origin, and that's going to be our horizontal dimension. And our drawing says that should be 6.5 mm in detail A. Okay. And then our vertical distance is 5 mm from the base of the flange. So we're going to go from the base of the flange to the center and hit OK. Now the last dimension we need is from center of this point to center of this point horizontally, and that gives us it's supposed to be 13. Okay, so we have the center places for the hole pattern. Now if you chose, you could draw circles and do an extruded cut, but we're going to use the hole command, and you can switch back to the solid mode so that the hole command is available. Select on your 2 holes. You're going to set your diameter to 3 mm, and it's going to go a distance. You're going to change that to through all. And then that way it'll drill the holes through both flanges that are aligned. If you have to change the pattern, you'll be able to change the sketch and move the holes. We'll hit OK. Alright. So if we've done everything properly, you should be, at this stage, you should have about 4 sketches, all these features defined, and then we're going to go to the next step. This is the next step is to demonstrate how to flatten this pattern. You're going to return to the Sheetmetal package, and there are 2 methods. The first method is to unfold the shape. The second is to create a flat pattern. There's some semantics to the difference. The flat pattern doesn't allow you to come back and do additional features and fold the model back up. So you need to make sure that your flat pattern is your model is absolutely perfect before you create a flat pattern. The advantage of it is it does generate theoretical bend points. So if you're trying to get dimensions off for a flat pattern on where to actually bend from, it will give you that information. But for the purposes of this project, I think we're better off using the unfold command. And it's the first one here under the modify under the Sheetmetal. Select unfold, and it asks you for a stationary entity, and you generally want to select the largest portion of your base flange because that's going to be the largest volume. Select the base flange, and it will by default, if this box is checked, to unfold all bends. Now you can deselect that, and you can go through and selectively bend it. Everything that's highlighted in green, it's going to attempt to unfold. Okay, so we're going to unfold all bends, and we'll hit OK. And then at that point, you're going to create a feature on the tree here that's called an unfolded model. And what this allows you to do is, if you're going to do a drawing of this, you could do a separate drawing of it in the 2 different modes. Now to return to the folded up model, you're just going to select this refold icon, and it'll fold it back up for you, but the fold is still in your history here, so you can always return or reference it when you create a drawing. There we go. We've done all the steps to model the TCOSE-14 part, and hopefully this was helpful for you, and we'll catch you on the web on the next one.